Dear boys, I'd like to welcome all of you on our online class again. We are just reviewing chapter 14 on my previous class. We had discussion on the different kinds of diagnosis instrument from this chapter, and as diagnosis instrument we had discussed about x-ray machine, and at the same time we had a discussion about ultrasonography machine. And in today's class I would like to discuss on CT scan, another diagnosis element, and I will also discuss about the MRI. These are so much important diagnosis element. These are just blessings to us because with this element it has become possible to diagnose many kind of critical diseases. This is very important for us to know about this device, their uses, and their details procedure. So let's start the class. We will just try to first discuss about CT scan. What is CT scan? The full abbreviation of CT scan is computed tomography, where a CT scan or computed tomography scan is a medical imaging procedure that uses computer processed combinations of many X-ray measurements taken from different angles to produce cross-sectional images of specific areas of a scanned object. That means from this definition, or from this discussion, we have known a new word, tomography. The tomography means whenever we are trying to know details of an object, and for that we have made some cross-sectional area of that object. So this cross-sectional area are cross-sectional images are called tomographic image. So before CT scan, total area or total parts of body that I have to scan or I have to examine, that is made to many cross-sectional areas, that is divided into many cross-sectional areas for creating images. So to produce cross-sectional image of specific areas, these cross-sectional areas are called slices. So and when it is scanned, allowing the user to see inside the object without cutting. So actually we are not cutting the object, we are just cutting the images of that object, and finally combining all images we just can get a full image of a specific portion of our body. So, Nobel Prize was awarded jointly to American physicist Alan M. Cormack and British electrical engineer Godfrey for the development of computer-assisted tomography, as this is a very important invention. So these physicists were awarded with Nobel Prize. And we have just got the basic idea of CT scan now. Then basic principles of CT scanning. What are the basic parts of a CT scan machine? First of all, if we just observe the diagram over here, this is a diagram of a CT scan machine, where the machine includes and a rotating X-ray source, a motorized platform where the patient are just allowed to lie, and there is specific direction for rotation, as by rotating the machine from different angles, different images are taken. So there is a way of rotation, and the direction of rotation is also directed over here. Rotating X-ray machine that generates X-rays by which the images are taken. There is a monitor to observe the images created by the X-ray source. So these are the very common parts of a CT scan machine. Unlike a conventional X-ray that uses a fixed X-ray tube, as we have known earlier on our last class about X-ray tube that is used to generate X-ray in an in a conventional X-ray tube uses a fixed X-ray tube, but a CT scanner uses a motorized X-ray source as it is a motorized source, so it allows the machine to rotate around the circular opening of a donut shaped seat. During CT scan, the patient lies on that bed that slowly moves while the X-ray tube rotates around the patient, and so shooting narrow beams of X-rays through the body. That means the patient is just lie down on a fixed platform, motorized platform, and that just can rotate in a circular way, so that from different angle X-ray tube can emit X-ray to that patient, and X-ray beams just pass through him, and from different angles different kinds of images are taken by this system. So instead of film, CT scanners use spatial digital X-ray detectors, which are directly opposite the X-ray source. As we have told about the image of CT scan, that this uses a X-ray source. There is also a detector, X-ray detectors, which are directly opposite the X-ray tube. That means a patient is just kept in the middle of the X-ray source and detectors. As the X-rays leave the patient, they are picked up by the detectors and transmitted to the computer to examine the response of X-ray they have transmitted to the patient. Each time the X-ray source completes one full rotation, the CT scan computer uses mathematical techniques to construct a 2D or two-dimensional image slice of the patient. That means we have done a single full rotation, and then we have got an image. After finishing one full rotation, then the patient is allowed to move forward or allowed to change his position with his motorized platform, and then another image is taken from another angle using the X-ray source. When a full slice is completed, the image is stored and the motorized bed is moved forward, and X-ray scanning process is repeated to produce another image slice. In this way, moving the patient forward gradually, the image of many slices of an organ of body is recorded. That means we are just making slices of images of a specific organ, so that it gets very clear to anyone who is observing that patient. Sometimes a contrast dye is also used because it can help to show certain structures more clearly. If we want to examine certain structure more clearly, then contrast dye can be used here on during CT scan. What is the function of contrast dye here? For instance, if a 3D image or three-dimensional image of the abdomen is required, the patient may have to drink a barium meal. Whenever a patient allowed to drink barium meal, the barium appears white on the scan as it travels through the digestive system, so it gets better, or it becomes easy, it becomes more um, um, it becomes more easy for the it becomes easier for the supervisor, for the observer to examine that portion of the body. So these are the common terms about the CT scan machine and its function. In a motorized bed, a patient is allowed to lie, and from different angle, X-rays are just emitted, and these X-rays pass through the patient, and by a detector, the passed X-ray or transmitted X-rays are then detects, and these are just observed. These images are recorded, and then total output or total image of an organ is created in this way. For example, whenever we are just trying to, if we try to say about a complete loaf of bread, by arranging the many slices with one another on that way, we are in this CT scan, we are making many slices of an organ, many slices of image actually of an organ, and then combining all those image, we just get a full clear image of that organ. So this is the most prominent term about the CT scan, and why it is more advantageous than the X-rays. What are the uses of CT scan? The uses of CT scan, or the CT scan is used to take image of soft tissues, blood carrying arteries and veins, lungs, brain, etc. Can be found if on this tissues or arteries or lungs or brain, is there any problem, is any problem arises over here, then that can be found by doing a CT scan. The scan is used to diagnose cancer of liver, lungs, and pancreas. CT scan image can detect tumor, can also detect whether there is any problem in blood circulation of the body. These are the common use or most prominent uses of CT scan. So there are some other uses. You just can know about, you just can learn more about the use of CT scan if you just have a look on your book. During CT scan, we have to keep some points in our mind that for as these use X-ray or X-ray radiation, so this is not done for pregnant women. That means this is harmful for a pregnant woman, and at the same time, for special purpose, sometimes as we have told that sometimes contrast dye is used, so that may cause some allergic reactions to some people. That also varies from people to people, but this is a negative point about a CT scan machine. So these are the overall discussion about CT scan. And now we will try to learn about another diagnosis element, that is called MRI, magnetic resonance imaging. As the name depicts, magnetic resonance imaging here, the magnetic properties is involved in this machine. MRI is a non-invasive test used to diagnose medical conditions. MRI uses a powerful magnetic field, as you all of you know about electric field, just like that, where a magnet has its reaction or ability to attract other magnetic element. So the area where that field just works, that is called magnetic field. So MRI uses a powerful magnetic field, a radio waves, and a computer to produce detailed pictures of internal body structures. MRI doesn't use radiation, and that we have learned earlier that X-ray and CT scan as well, they use radiation, but MRI doesn't use radiation. That is a positive point about MRI. MRI scanners are particularly well suited to image the non-bony parts or soft tissues of body, as X-ray mainly used to examine bony parts, and CT scan can detect bony and non-bony parts, but MRI is specially suited for non-bony parts or soft tissues of body. They differ from CT scan in that they don't use damaging ionizing radiation of X-rays. That means there are no radiating element are used here. So this is more positive. The brain, the spinal cord, and nerves, as well as muscles, ligaments, and tendons are seen much more clearly with MRI than with regular X-rays and CT scan. These are the fields where the MRI are used mainly. Then how it works, the human body is mostly water. All of us know that human body is mostly water, and water contain hydrogen nuclei, and that is called protons, which become aligned in a magnetic field. Protons, when magnetic field are applied on there, they are just aligned in a befitting manner. An MRI scanner applies a very strong magnetic field, as this is the name is magnetic resonance imaging. So MRI scanner applies a very strong magnetic field, that ranges from 0.2 to 3 Tesla. Here Tesla is the unit of magnetic field. When very strong magnetic field is applied, this helps to align the protons there by their spins. The scanner also produces a radio frequency current that creates a varying magnetic field. Scanner not only generates a magnetic field, that also produces a radio frequency current that creates a varying magnetic field. The protons absorb energy from the magnetic field and flip their spins. This process is called nuclear magnetic resonance. That means the protons try to align with their spins after the application of magnetic field. These properties or this process is called nuclear magnetic resonance. When the field is turned off, the protons gradually return to their normal spin, but while returning to their normal position, normal spin, they just emit some energy, and that energy are or that signals are just observed by the machine. The return process produces a radio signal that can be measured by receivers in the scanner and made into an image. That means the energy emitted by the protons while they are getting back to their normal spin, that energy is converted into a radio signal, and then it is just made into an image. MRI is possible to tell the difference between the diseased tissue and normal tissue, as the protons, a tissue or an organ of our body contains so many tissues. So if these tissues have reaction after applying a magnetic field, and whenever they just gets back to their regular spin or regular position, the emitted energy, from the emitted energy we just can form different image, and from that image we can differentiate between a diseased tissue and normal tissue. These are the diagram of MRI scanner or MRI machine that includes patient table scanner, as it generates strong magnetic field. Definitely the machine has a magnet, gradient coils, radio frequency coil that generate radio frequency here. And this is a simple diagram of MRI machine, of an MRI machine. And some key points we have to keep in our mind while doing MRI. Metallic device shouldn't be kept aside because radio frequency wave can create dangerous situations because of heating up the metal. If we have any if the patient have any metal element with him, that can create problems here. So this is told to a patient to leave all kinds of metallic element. Special care should be taken for pregnant women, and there may arise problems for patient with history of kidney problems and diabetes, or having any other diseases. Also special care should be taken for those kinds of patients also. So these are overall discussion about CT scan and MRI machine. As I have told you earlier, these are two very important diagnosis element. So you just try to know in details about this element, and if you have any question you can ask without any hesitation. But after our class, when we just try to get some review from you, get some response from you, your responses are very poor, and that is quite disappointing. As your if you could have your regular classes on your classroom, you had to attend or give attention to class. So I hope you will try to observe the classes. You must pay your attention to classes, and you will just try to understand the lectures as well. And you just mm, you must make a very good result on your exam, as you have another in-house test at the end of this month. So just get prepared for that, and best of luck. Goodbye, all of you.